Right. So today we're going to start a new topic, multicasting. Multicast. What do you know about multicast? Anyone?
One too many.
Is multicast correct? One too many. Is unicast or broadcast or multicast? Which one is better? Which one do you think it is good? All are good. In IPv4, all three are good. But from the security perspective, broadcast is seen as bad, so in IPv6 we don't have broadcast. Multicast is good than unicast when you are talking to a group. We have a very large network. We don't want to talk to everyone in that large network. We just got few destinations, a group of destinations to whom we want to talk. Let's say we got 1,000 devices, among which we got only 50 devices to communicate. For 50 device, if I use unicast, then the packet needs to be duplicated 50 times because you got 50 different destination address. So what happens is, if I am sending 1 GB of data, then it is going to be 50 GB of data. 50 GB of bandwidth, 50 times bandwidth is more, 49 times more. When I use multicast, just one packet to all 50. Unicast is good only when you are talking to one single destination, one particular destination. Multicast is good when you are talking to a group. When we want to talk to all, broadcast is good. All means any. We have no idea how many. It is simply any. That is broadcast. It may sound like a good one, but it is not. Broadcast is not at all good because it is any. No idea whether our own destinations receive it or some attacker's destination also may receive it. So broadcast is bad really. But when we are talking to multiple destinations, like A is one destination, B is another destination, C is another destination, whereas D is not a destination to where you want to go. You see, from alpha you want to go to A, B, C. These three are the destinations to which you want to send same data. If I do unicast, then the data that I want to send will have A as the destination, send. Again, another copy of the same data, B as a destination, send. C as a destination, send. So bandwidth consumption is now growing more. More destinations, that many times you need to duplicate the packet, and we need to put different destinations. So process utilization is going to be higher, bandwidth utilization is going to be higher. Instead, if I use multicasting, then just only one copy of packet, and I'll have multicast address ABC. Only one packet goes to this router, and this router finds that this belongs to ABC, and it knows A is here, it sends it. A copy is sent to B, a copy is sent to C. So multicast is good when you are sending to a group. Unicast is good when you are sending to a particular device. Broadcast is good if you don't know to whom you want to send, but you want to send to everyone. You want to send, but you don't know to whom to send. You want to send. You may want to send to everyone, or you may want to send to someone whom you don't know. Then what do? You send to everyone, that someone will also receive it. That is how ARP works, right? ARP, layer 2 broadcast. You don't know who is 10002. You want the MAC address of 10002. So what happens? Flooding broadcast. It is not good actually. Because of that broadcast, only the man in the middle attacks becomes possible. By the way, just for an information, I want to share you something. You see, this is the files that have stolen our channel. You know how they took over our channel? They will keep on sending me mails saying 30-second advertisement, we'll give you this much. In your YouTube channel you got a lot of subscribers. Just 15-second advertisement. And I was ignoring for many months. And one day I was just trying to see what they are really up to. Is it really a honest group? Will it help me? Something like that. And they said, we have an attachment of MP4 format, file. That is the video that we want to promote, and this is the document. We'll explain you about our product. If you are happy with our promotional video, there is a small form in the document. Fill it and send it to me. So I just double click this docx file after downloading, and nothing comes. Actually, it is a screensaver type. It is shown screensaver type file. It's not really document. Now only I noticed, yesterday only I noticed. So why I'm saying this, be careful about these type of thing. It may look like document file, it may look like MP4, it is not. It will copy your credential from your laptop when you reload your computer, and it will send it to that the group who wants to take control of your accounts. Careful, careful, careful. So multicast is good when you are talking to a group. Multicast will reduce the bandwidth utilization if you replace multicast with unicast with multicast. If you replace multicast with Just replace unicast with multicast. Instead of sending to 3 different destinations, you just send it to the group address. Group address is the key. Group address. What is a multicast address? The address that talks to a group. The address that identifies a group is a multicast address. The address that identifies a group. For that, we got class D range. Address starting from 224.0.0.1 to 239. We call it as multicast range address. Multicast range. So this address is not to identify a single computer, but to identify a group of computers, group of routers, group of device. OSPF uses 224.0.0.5. Why? Because when OSPF sends hello, it don't know the destination to whom it is sending the hello for the first time. When we enable OSPF, they send the hello to discover the neighbor. They send the hello to discover the neighbor. For example, if this router is running OSPF and this router is just configured with OSPF, the hello will go and discover ABC. How it discovers? The hello packet is sent to the destination 224.0.0.5, to which all the OSPF routers are tuned. They are tuned to that address, meaning only the OSPF running routers will be able to accept this hello packet. So these 3 devices receives the hello packets. This one, no. Because that router don't run OSPF. It may be running some other protocol. It's not running OSPF. So only the OSPF enabled routers receives this packet, processes it, and when A sends the hello packet, this also sends the hello packet to 224.0.0.5, which is received by B, C, and alpha. You see, they don't really know any neighbors initially. Without broadcasting, just by multicasting, just by sending the packet to this address 224.0.0.5, which is reserved for OSPF, they can know each other. And the bandwidth consumption is not too high, you see. Just only one packet, but still it can be a reason for discovering 3 neighbors ABC. Or ABC can learn alpha just in one small packet, likewise when A sends hello packet to that multicast address, alpha, beta, alpha, B and C can learn about A. Multicast is good. If you don't have multicast, then it is very difficult for protocols. We need to manually configure the neighbor like you configure in BGP. Like we configure in BGP, we need to configure manually all the neighbors So multicast is good in a secured environment. You can use this multicast to discover neighbor, not only for protocols. The same multicast can also be used by applications in your organization. By the applications, like some applications, they want to call people for a conference, a video conference or online conference room that needs group. Nowadays we're all staying at home, and most of the time you don't go out for work, but the meetings happens as usual. Though we stay at home, we enter into a boardroom, we enter into a discussion room with our colleagues using a multicast application. Why multicast application? When I speak, you all hear me, which is a multicast. Only you are hearing me, not the entire world is hearing me. When you speak, I and other colleague hear you. When you speak, we all hear you. Even if all wants to talk at the same time, we can talk. Though human being, we can't understand because we are all talking at the same time, not good. But the multicast will support. When I speak, a copy of my packet goes to a multicast address to which you are all mapped. One common address to which you are all mapped. That is why you are hearing me, not the others. To the same address, I am also mapped. So when you speak, I also can hear like others can hear you. That's one example for multicast application. This application may be worldwide, like what we are using now, or it may be within an organization, your organization's own application that will work only within your LAN. You might have seen one like that. Or there may be an application that is used for internal chatting inside your organization, to chat with your colleagues. You may have application. For example, I have seen, in some technical call centers, they will have, I don't know whether it is available in other call centers, but in technical call centers I have seen, someone will be taking calls, and that someone will have a doubt. He don't know what to answer the customer. So there's a query, he immediately types in the chat window. His team members, not the entire office, his team members can see his query. So that one of his team member who knows the answer for the query, he answers. And this guy copies the answer and he speaks to the customer. So he can take help in the runtime using the application, which is using multicast. So when he puts the query, immediately all his group members receive the query. And one of the group member who knows the answer answers, and it comes to everyone, not only to the one who queried. We might have seen this. Definitely you all have seen this. And when you answer, you can also answer to one particular participant or to all participants. You might have seen this in Zoom, Cisco WebEx. So all these uses this multicasting, talking to a group. This is the range of multicast address, but there is some reservation. See, 224.0.0.0 to 224.0.0.255 is reserved for 224.0.0.0 to 224.0.0.255. It is reserved for all routing protocols. You can see that here. This is the base address. This is all system in this subnet, means within the LAN. All routers in this subnet. That is also LAN, but to the routers, not to the system. This is unallocated DVMRP. See the OSPF that we were talking to all routers to the designated router. Likewise, we got a reservation for various services up to this. Again, we got some more reservation. You see, 224.0.011 is for NTP. So if you see unreserved, 239 is better to use. See, there are some reservations for various services. 233 is also used. So better to use 239. Look at this. Organizational local scope. So you can have your own applications. You can use your own multicast applications. If you are designing a multicast application to use within the organization, you may use this range. This is better. So I'll be using this as the range to do demos. So what we have seen is, even though we have 224.0.0.1 to 239.255, it is advised to use only this range, 239.0.0.0 to 239.255. 255. With this, you can have millions of multicast address, so it's enough. It is sufficient for developers who develops application to be used within an organization. 239 range is unreserved. It is good to do the testing with 239, not as 238 or 237 or 224. When you do testing, you just use this. But in a lab environment, you can use anything. In production, if you're developing an application that needs multicast, so use anyone within this range. That won't conflict with any service. It won't conflict with any service that is running. Next. There is a protocol called Igmp, Internet Group Management Protocol, Igmp. This is responsible for enrolling a device into the group. IGMP, Internet Group Management Protocol. For example, let's say this router has got a computer that runs some application. That application is embedded with this multicast address 239.111. There is a multicast source here who is ready to send the traffic to anyone who belongs to 239.1. This is a source from where the data will be given to this application. So you can call it as it's a server application, this is a client application. There is another computer here. This computer is also running the same application 239.1.1. So as soon as you double click that application on both computer A and D, using IGMP it goes and tells the router. Using IGMP it goes and tells the router, if you will see any traffic coming to this destination 239.111, we need those traffic, send it to us. Yeah, so A and D uses IGMP to tell the router 3, router 6. It tells router 3 and router 6 that if any packet someone sends to this address 239.111, you please forward it to me. So this computer may have an IP address 10.0.0.1. This computer may have an IP address 15.0.0.1. They got two different IP addresses, but they got one thing in common. What? They belong to this group now. They have their own IP address. They have their own IP address, a unique IP address. Plus, when they started the client software, they also take another identity that belongs to a group. So A and D now has got a unique identity called 239.111, and router 6 and router 3 knows that we got someone with IP address 239.111 whose original IP address is 15.0.0.1. See, you may be having a switch here, you may be having many computers. But the multicast destination is not all the computers, only this computer. This computer's IP is 15.0.0.1. So router 6 knows that if I'll receive any packet to 239.111, I need to forward to that black computer.
No.
Sorry, it was mute. So let me repeat again what I told. See, A and D computers, they have their own IP address 10.0.0.1 and 15.0.0.1. Likewise, this may have 13.0.0.1, 12.0.0.1. Only this 15.0.0.1 and 10.0.0.1 is running this client software. That software is coded embedded with this address 239.111. So A and D sends the request to router 6. See, I got 15.2 here, 15.0.0.3 here. But the request to router goes from 15.0.0.1 using Igmp. It goes and enrolls to the router saying, I'm coming from 15.0.0.1, but I also belong to this multicast group 239.1.1.1. If you will receive any packet to 239.1.1.1, you just forward a copy to me. So a copy will be sent to this computer if router 6 receives packet to 239.1.1.1. Likewise, A is enrolling using Igmp. Now, this multicast source is sending the traffic. What is the source? Let's say 1.1.1.1. So now a packet comes out from this router 1 with the source address 1.1.1.1 and destination address 239.1.1.1. When this packet goes to this router 2, router 2 will forward it to router 3 and 6 alone if it is multicast sparse mode. But if it is dense mode, it will go to every router. Router 4 will also receive, router 5 will also receive. I should not say receive. Router 4 and router 5, they will see it, but they won't receive it. Why they won't receive it? Because they don't have any client. Only router 3 has got client and router 6 has got client. So router 3 will receive it and forward it to this computer A. Router 6 also will receive it and forward it to this computer D. Whereas on router 4 and 5 it will be pruned. It will be pruned back. Because router 4 and 5 is not receiving. It is seeing it and it is not receiving it. It can see but it won't receive. Because there is no client to accept the packet. We call this as flooding and pruning method. And we call this as dense mode, dense. Dense mode is nothing but flooding the packet to everyone. But whoever has got the group member, they alone receive it. Others prune it. Dense mode is not scalable, not good. Fine. Even for this dense mode or sparse mode, you need another protocol. Igmp alone is not enough. For this multicast packets for this type of multicast address to go on the link, what is needed is, on these links, we should enable protocol independent multicasting, PIM. PIM is needed. This PIM only has got these two modes, dense mode, sparse mode. PIM dense mode, PIM sparse mode. PIM dense mode is flooding and pruning. PIM sparse mode is learning both source and group and sending only to the group member, learned group member. That is sparse mode. PIM dense mode, PIM sparse mode. Two modes. As I said, sparse mode will not flood to everyone. It will forward only to those who have got some clients to receive it. Why long silent? Why no questions today? It's only your evening, not early morning like mine. Why long silent?
Aaron,
Yes.
can you go back to the previous slide?
Yes.
So can you just tell us sparse and dense mode difference here?
Coming there. Yes, you see, sparse mode is sending only to router 3 and router 6, not to router 4 and 5. For that, router 2 should know that router 3 and router 6 have got some clients, receivers. How router 2 will know? With the help of something called rendezvous point, which I am about to teach in the next diagram. But for your question, what is the difference between dense and sparse mode? Sparse mode is more intelligent multicast network. The network itself know that there is no receiver on R4 and R5, so I should not send towards R4 and R5. That is sparse mode. Dense mode don't know where the receivers are. Wherever PIM is, dense mode will flood it. PIM is running on every link, because in future there may be a client here. So PIM will be running all throughout your network. So wherever the PIM is running, dense mode will flood the multicast traffic. Dense mode will push that multicast traffic on all the links where the PIM is running. Whereas sparse mode will push the packet only on those links where the true receivers are. The receivers are here, the receivers are here. So it will send it only via these two wires. After coming from here to router 2, just 2 copy, one to router 3, another to router 6, because the multicast network is aware of the receivers. In the sparse mode, router 2 is aware of who has got the client, whereas in dense mode, router 2 has got no knowledge of the clients, so it sends to every PIM enabled link. Did I answer your question, Murli?
I'm sorry. Yes, but I have a question. Who will as admin, who will group? Okay, this is
no worries. That is what the next diagram will explain. Wait for that. We'll discuss in depth now. Yes, question please. Next question.
What is PIM?
Protocol independent multicasting. That is the protocol that enables multicast support on that link. Multicast support between R1 and R2. If you want, then you need to enable PIM on the link that connects R1 and R2. If you want multicast support all throughout the network, then we need to go to every link in the network, enable this PIM, and this PIM only got two modes. One is dense mode, which will not know where the receiver is, so it will need to flood the multicast traffic to every link. Whereas sparse mode knows where the receivers are. It sends only to those routers where the receivers are connected using IGMP. So the scope of IGMP is only here, only within this rectangle. Whereas PIM has got scope between this end to this end. PIM only carries the traffic from this left hand side end source router to the right hand side end destination routers. Between the destination router and the client, between the destination gateway, means router, and the client computer, the IGMP is there to tell the router that I need any traffic that is coming to 239.111. Did I answer your question?
Yes. Yes.
Thank you. Another question? All right.
So
Yeah.
So we will advertise. How do we choose that multicast IP? Whatever that application uses, we configure that same IP under the multicast.
Yeah. See, usually you will not assign any multicast address. The developers who develops the application, they'll do it.
Okay.
They will put it in the application, and as soon as you double click it, that particular multicast address will be used by IGMP to send a request to the gateway. So you are downloading a software, you buy a software, you are downloading it, and when you double click, that application will go to the route, that application will use the hidden multicast address and go to your gateway, which is configured as a default gateway in your laptop. It will go to the gateway and it will say, if you find any traffic coming to this address, forward it to me. So when server sends the traffic using PIM, the server will be forwarding to all the routers, and when this router where the receiving client is, when this router receives it, it will forward to the client. Right. So, for example, you see, you got a server here. And we got client 1 running in this computer, client software. Among these 4 computers, only 2 computers are running client software. Now, as soon as the software is on, as soon as you double click, when it is opened, the multicast address which is hidden there in the application, let's say if it is 239.2.2.2, see, already these computers and routers are communicating with their own IP address. For example, this one has got 10.2.0.1, 10.4.0.1. So using this address, they are already communicating to the router. R5 and R7 now knows that I got a client that belonged to 239.2.2.2. We did not configure anything here. This is automatic. This client software is designed to use IGMP, Internet Group Management Protocol. Using this source address, it goes to the gateway and say, I am one of the group member of 239.2.2.2. So if you will find any traffic coming to you, you're supposed to send it to me. Don't forget me. I am 10.2.0.1. Likewise, this computer says I am 10.4.0.1. If you find any traffic coming to you to the destination 239.2.2.2, you're supposed to forward it to me. Don't forget. So router 5 and router 7 knows now that I got a client. Fine. Now we are running PIM everywhere. That is mandatory. Protocol independent multicasting.
To manually do that.
Yeah, PIM need to be manually configured. Either source mode or dense mode you have to enable. One more time, I want to explain the dense mode. Then I'll come back to the sparse mode. Yeah, only question.
So before this grouping, multicast application grouping, okay. So we need routing between communication, right? From R1 to whatever the router. We need communication using routing protocol, correct?
Of course it is. Yes.
So usually for the routing protocol, multicast using multicast address, they will talk, correct?
Yeah.
So but we don't mention anywhere PIM. One thing that is automatic grouping using multicast address, correct?
Okay, let me tell you that's a nice question. What Morley is asking is, what is this PIM? We had OSPF, we had EIGRP, we had RIP version 2. They all use multicast. When did we enable PIM? See, that PIM is not needed. Why the PIM is not needed there? The scope of that multicast packet is only one hop. It will send on the link where you enable OSPF. On the other end, it is going to receive. It is not more than one hop. Did you send anywhere in OSPF more than one hop? Not possible. You run OSPF here and don't run OSPF here, and you run OSPF here. Will they form neighbor? No, they cannot. So the scope is only on that link. There is no need for PIM. Just one hop. What will be the TTL value? Only one hop. But this is not that story. The client may be 100 computers away, 100 hop away, maybe 2 hop away, who knows. Did I answer your question?
Yes, correct. But even though if you enable, we need routing protocol, right? Any local protocol.
See, routing protocols are mandatory. We are not replacing routing protocol here. Using the reachability between R1 and R4, R5, R6, R7, we want to send some packet to group. So definitely routing is mandatory. You can have static route, you can have OSPF, EIGRP, it can be anything. All that we need is first ping between these routers. Not only this router, even the computer and the end 10.2.0.1 should be pingable from the source computer. The source computer may be 10.1.1.1. there should be end-to-end reachability. Instead of doing unicast, we are trying to have multicast so that the bandwidth will not be unnecessarily consumed. We can avoid duplicating the packet for multiple destinations. When you have multicasting, only one packet goes, and only when it is necessary to duplicate, it will duplicate. Yeah, Murli, question.
So if the hop is away more than one hop, we might use BGP or any protocol to communicate. Right? One end to another end. So PAM can enable over the unicast like not minicast or like that kind of
we don't call PAM, it is PIM.
PIM.
Tell me now, what is the question?
So here in the example from R1 to R4, two hops away. Let's say if those two are in different location. Correct. So that pin can travel over the, let's say, BGP enable on R2.
You want to? Your question is, can we enable multicasting for layer 3 VPN? Is that right? Hello, you said different sites, right?
Yes, correct.
Definitely, you have a layer 3 VPN.
Okay.
Yes, you can enable multicast support on the tunnel. Layer 3 VPN. Yes.
Okay.
So, what Murli said is between R1 and R4, we got a big internet, not simply one router. So, definitely there will be a tunnel between R1's provider edge to R4's provider edge. We call it as L3 VPN. On that L3 VPN, you should have this PIM support so that the multicast packet can travel over that layer 3 VPN. Okay, now let's come back to our story here. You see, we got Igmp protocol to enroll to the gateway, and between these gateways we got PIM running between the source and the destination gateways. PIM is running everywhere. Only if the PIM, for example, if you don't have PIM here, when this server sends the multicast traffic, source 10.1.1.1, destination 239.1.1.1, sorry, 239.2.2.2.2. In this example, I changed it to 2.2.2. Earlier I was saying 1.1. Okay. Now, when this packet hits router 1, router 1 will send on this link, not on this link, because there is no PIM. So what I am coming to say is, if you will do this mistake, then R7 cannot receive the multicast traffic. You got PIM here, but problem you don't have it here. So please be careful. Make sure you run PIM on all the link in the transit. Fine. Here comes the main story, the Sparse mode. If no Sparse mode, what will happen? This packet will go via this link, this link, this link, this link. All the links. But this here it will be pruned, here it will be pruned, meaning it will not be accepted. Wherever PIM is, it will go, but because there is no receiver, R4 will not process it. R6 will not process it. But R5 will process it because R5 knows through IGMP that I have a receiver, so it will forward here. R7 will also receive it and forward it. Here unnecessarily bandwidth utilized between R2 and R5, R3 and R6. Unnecessarily bandwidth utilized. Now let's say we don't have this IGMP group member. We have here 239.2.2.2. His original IP address is 10.3.0.1. So the group members are only on R6 and R7. Again, if you don't have sparse mode, wherever PIM is, the update will go. This will prune, this will prune, this will prune. So what happened is we have wasted the bandwidth here, here, here. We have wasted. This is good because you got some destination via router 3. This is good because you have destination via router 6. This is good, we have destination via router 7. Unnecessarily, a copy was sent to router 2 and router 2 was sending to router 4 and router 5, which can be avoided if you are enabling sparse mode. How? Sparse mode is not flooding and pruning. Dense mode is flooding and pruning. PIM dense mode is flooding and pruning. PIM sparse mode is you decide a meeting point, a gathering point. We not dynamic. We need to decide a gathering point. For example, if you have a router here, we configure this router as rendezvous point. Rendezvous point. Anyone knows the meaning of rendezvous? French people? No French speaking people in class? Rendezvous means gathering point, meeting point. Meeting point, rendezvous point. So we configure a rendezvous point. Why do we need this? As soon as this computer joins the group using IGMP, R6 will go to rendezvous point. R6 will go to rendezvous point and say, hey, I got a receiver. I got a group member. I got G, group member. So please make sure that you will forward it to me. Likewise, R7 will go, because there is a group member, to RP and say, I got a receiver. Now RP knows that I need to send a copy to R3. R3 knows that I need to send a copy to R6 and R7. So when a multicast packet comes, the source will also go to RP. The source will go to RP and say, RP, I am coming from this source 10.1.1.1. I am responsible for the group 239.2.2.2. So RP knows the source of the group. RP also knows the group members, which are R6 and R7 as a result. Through RP, a connection is established using the shortest path. It need not to go always through RP like this. Through RP, the source is known now. See, the source is coming and registering with RP. The group member is also coming and registering with RP. Now the group member knows the source. Using the reverse path forwarding, R7 will take this path straight to the source. R6 will take this path straight to no need to go via RP anymore. So now when the source sends the packet, it goes only to R6 and R7, not to anyone, any link, any router. So using the gathering point, they both meet and they both know each other. Group member knows the source and source knows the group, and they know whom should I send and whom should I ask. And they use their own routing table to find the shortest path to reach the source, and they go and receive the multicast feed from the source. That is what sparse mode is. That is how you avoid flooding and pruning. Question, please. So this rendezvous point needs some configuration, which we need to do manually. And every router should know the location of rendezvous point. That can be learned dynamically, can also be configured statically, manually. We'll talk about that in coming class. This rendezvous point is the one which learns both S, G, source and group, via which the other routers will know about the source. More is coming in our next class. We'll talk about sparse mode. We'll begin again one more time with sparse mode. We'll go deep into it and then we'll see a demo on both dense mode and the sparse mode in our next class. So
Because those are physical
this rendezvous point can be decided by you. You can have anywhere in your topology. If you find one router as a middle for all other routers, you can pick that router. That router need not to be in the transit. The router need not to be in the transit. It can be in one corner also. So everyone will go to the rendezvous point, know the source, know the group member, and then they will find their own path to establish connection, to send and receive packets. They will find their own path using reverse path forwarding. So no need to worry where to put RP. It can be R6 also. RP need not to be there in the middle. In the recommended is try to keep it somewhere in the middle. The RP can be router 5 also. It can be some one corner router. Not a problem.
Okay, but we are doing manually like this is source and this is destination.
No. We just configure RP alone manually.
Okay.
And we will tell every router that this router is what RP is. So if there is a source, it will go and tell to RP. If there is a group member, it will go and tell to RP. They themselves will go and register. Alright?
Okay.
We'll go deep into this story in our next class. Thanks for